Hello everyone. In my previous lecture, we have studied about the slope deflection method and how it is used, why we are using that equation, for which condition we are taking that slope deflection method, all the things that we have discussed in our previous lecture. Now, today we are discussing on the example how we can calculate the shear force and bending moment values and how we can draw that diagrams for shear force and bending moment. So dear friends, let's start with some background about the previous discussion. First, it's very important, the slope deflection method is create good background for the moment distribution method. Nowadays, moment distribution method is most important for the analysis of continuous beam. In previous lecture, slope deflection method was discussed all the things, and today we are discussing about the examples with shear force and bending moment. For the solving of the continuous beam, first we have knowledge about all the steps which are used for the analysis of continuous beam with the help of slope deflection method. The first step is fixed end moment, and from where we can get the fixed end moment. In my previous lecture we have discussed about the fixed end moment, and you also have studied the whole chapter of fixed end moment. So fixed end moment is depending upon the type of load that can acting on the beam. In this lecture we are discussing the fixed end moment, and it is indicated by MFAB and MFBA. MFAB means fixed end moment from A to B, and MFBA means fixed end moment from B to A. Now, step number 2, slope deflection equation. Slope deflection equation. We have slope deflection equation which derived in our last lecture. The equation is MAB, means moment from A to B. MAB is equal to MFAB plus 2EI upon L, 2 theta A plus theta B minus 3 delta upon L. Here there is some trick for memorize this equation. MAB means fixed end moment is also MFAB, and in the bracket there is a 2 theta A, means here moment at A to B, therefore theta A is 2 times and theta B is single times. Similarly, the second equation is MBA is equal to MFBA 2EI upon L in the bracket 2 theta B plus theta A minus 3 delta upon L, means here we are calculating moment from B to A, that's why theta B is going to be taken here 2 times. Okay, the most important step, that is equilibrium equation. So Number 1, here two span continuous beam A, B and C. Support A and support C both are fixed, and we know that there is slope is 0 at fixed support, but in a simple support or else in a hinge support slope is there. That's why in this equation theta b is going to be calculated. So unknown is theta b, and what we are going to do, we are going to balancing this rotation with the help of slope and deflection. For that we are considering that moment from B to A plus moment from B to C should be 0. Summation of moment from B to A plus moment from B to C is 0. Second number, there are 3 span continuous beam A, B, C, D. In that case, again A and D support both are fixed. That's why theta A and theta D both are 0. But unknown is theta B and theta C. For finding out these two unknown, we are considering two equilibrium equation, that is moment from B to A plus moment from B to C is equal to 0, and second joint, that is moment from C to B plus moment from C to D is equal to 0. Means here we have a simple thing for memorize this. If there is a simple support, then we must take moment at that joint is equal to 0. If it is continuous, means that joint is connected with two span, then sum of that two span moment is equal to 0. Let's understand this. Number 3, this is again two span continuous beam capital A, B, C. Support A is fixed, means theta A is equal to 0, but here support B and support C both are hinged. That means theta B and theta C both are unknown. So how can we get that? Moment from B to A plus moment from B to C is equal to 0, and moment from C to B is also 0 because both are simple support. Number 4, here 3 span continuous beam and all the supports are simple, means unknowns are theta A, theta B, theta C and theta D. So how can we solve that? Moment from B to A plus moment from B to C is 0. Moment from C to B, moment from C to D is 0. Moment A to B is equal to 0 and moment of D to C is equal to 0. So these are the equilibrium equation. It is changed with case to case that we have discussed in our next session. Step number 4, simply supported moment, that we know about all the simple support moment. Here I have taken some simple example. Number 1, suppose this is a simple support span A, B, C, right? At center, that is C point, where point load W is acting, it is at the mid of the span, and the moment, span moment is WL by 4. Same way, simply supported with UDL, that is loaded by W kilonewton per meter, then span moment, that is WL square by 8. These things we have already studied. Now I am going to start the example. Example number 1, analyze the beam shown in the figure by slope deflection method and draw shear force and bending moment diagram. Here two span continuous beam ABC and support A and support C both are fixed and support B is hinged or simple. AB span having point load 40 kN, it is acting at the mid point of the AB span, and in BC span there is UDL 20 kN per meter and having span 6 meter. AB span is I, means its flexural rigidity is single, but from B to C flexural rigidity are 2 times, means depth of that B to C is more. Now what we are going to do for the analysis of this beam? So we have all the steps. Our first step, that is fix and moment. So what we are going to do? We are considering AB is a single span and it is fixed at both the ends. Then moment, fix and moment. MFAB is equal to minus WL by 8. This is the fixed equation and we have to memorize that equation for the fixed beam with point load at center. Then we can get the value, that is minus 20 kilonewton into meter. From B to A, same equation WL by 8, but the sign is positive because here we are considering the hogging moment, and hogging moment, that is left hand side moment is minus and right hand side moment is plus. Again for BC span, then fixed moment for the BC span is minus WL square by 12. It is fixed for the UDL and we can get the value, that is 60 kilonewton into meter, but it is minus because left side moment is minus and right side moment is plus. That's why fixed moment MFCB, that is plus 60 kilonewton into meter. The first step is over. Now step number 2, slope deflection equation. We have the fixed equation for the any continuous beam, that is first equation MAB. That equation is MFAB plus 2EI upon L in the bracket 2 theta A plus theta B minus 3 delta upon L. That we have already discussed in our previous lecture and we have derived that. Here we have theta A is equal to 0 because A support is fixed, and here we are considering delta is also 0. Why? Because there is no sinking of support. If the support is sink, then it is clearly indicated in our question, but here there is no sinking is given in example. That's why we are considering that the delta is equal to 0. Now what is the MAB? We are putting all the value in that equation and finally we can get moment at AB is equal to minus 20 plus 0.5 EI theta B. We are taking this as a equation number 1. Again same thing for B2A. So what is the change in equation? MBA is equal to MFBA plus 2EI upon L in the bracket 2 theta B plus theta A minus 3 delta upon L. Theta A and delta is 0. Again we get moment from B to A is equal to 20 plus EI theta B. This is our equation number 2. Now the same thing is for the next span, that is BC. MBC is equal to MFBC plus 2 EI upon L in the bracket 2 theta B plus theta C minus 3 delta upon L. Here again theta C is equal to 0 because fixed at C, and there is no sinking, that's why again delta is equal to 0. So we can get minus 60 plus 1.33 EI theta B. That is our equation number 3. Now moment from C to B, then equation is MCB is equal to MFCB plus 2 EI upon L, 2 theta C plus theta B minus 3 delta upon L. Theta C and delta is 0. Then we can get the equation that is 60 plus 0.666 EI theta B as equation number 4. So our second step is also over here, and we can get the 4 equation for the span 2, and that equation is indicated by the equation number 1, 2, 3 and 4, which is in the form of unknowns. Here we have a single hinge support at B. That's why unknown is only theta B. Now how we can get that unknown? With the help of equilibrium equation. That is our step number 3. At joint B, moment from B to A plus moment from B to C is equal to 0. This is our equilibrium equation. So here we have value of MBA and MBC, that is previously find out the equations. Now summation of this all equation, and we can get the theta B is equal to 17.17 upon EI, that is clockwise. Here we get the value of theta B, that is plus, that's why we are taking it is as a clockwise. Suppose we get this value as a minus, then that it is anti-clockwise. So now actually what happened in our structure? Here I have indicated that with the help of drawing we get the clockwise moment. Then from the support B, the whole structure is rotate in a clockwise, and it is deflect like this, which is given in the figure. Now final moment. So we have equation of moment AB, moment BA, moment BC and moment CB. We are going to put this theta B, which we have find that value put up in the all equation, and finally we get the final end moments, that is MAB is equal to minus 11.40. Here we can get the value that is minus, means the moment at AB is equal to anti-clockwise. Now moment from BA, which is after getting 37.20 kilonewton into meter, it is positive, means it is clockwise. Moment from B to C, it is minus 37.20 kilonewton into meter. फ्रेंड्स यहाँ पे ये दोनों वैल्यू moment from B to A and moment from B to C both are getting same value, means the rotation of theta B we can get from the equation, and after putting that the moment at single joint is same. Moment from B to A and moment from B to C means support moment, यहाँ पे हमारे पास सपोर्ट एक ही है B, तो एक ही सपोर्ट पे मोमेंट एक ही आएगी, दैट्स वाई यहाँ पे वैल्यू कॉमन मिली, दैट इज 37.20 kilonewton into meter, and moment from CB is 71.4 kilonewton into meter, it is plus, that's why it is clockwise. Now what we are going to do? Now we have all the values of moment at support, but our next step is finding out the span moments. For span AB, the moment is WL by 4, that we know, and that value is 40 kilonewton into meter, and for the span BC it is WL square by 8, this is the fixed equation, and it is 90 kilonewton into meter. So here we can get the first what we are going to do, we are draw the span moment. After that, at support, uh, what are the moments that we have find out? At support A it is 11.4, at support B 37.2, and at support C 71.4. Now the this support moment is joined by the inclined line and span moment that we know. For this simply supported with point load, it is indicated by the lines, and for the UDL it is curve, parabolic curve. So our bending moment diagram is ready. Now shear force diagram. Then how can we get shear force diagram? For that we must have to find out the reactions of this individual span, and after that we can get the shear force diagram. So for span AB, 40 kilonewton into meter at the mid span, and we have here support moment that is at A 11.4 and at B 37.2 that we have find. So what we are going to do now, we have to find out the reaction at support A and at support B, including moments. So we know about how to find out the reaction. So I have write down here directly reaction at A, that is 13.55, and reaction at B 26.45. Same way for a span C, again we are going to finding out the reactions with the help of moments. So we can get the reaction at B is 54.3 and reaction at C, that is 65.70 kilonewton. Now here we have all the reaction that is clearly indicated. Reaction at A 13.55, reaction at B is the sum of reaction at B due to first span and reaction at B due to second span. It is 80.75, and at C that is 65.70. So we are getting the shear force diagram. It is like that, and we know how to draw this shear force diagram. So friend, it is very much simple, and how we can get the bending moment and shear force diagram with the help of slope deflection method. Now another example, here I have taken a 3-span continuous beam with the help of 3 equal loading. So let's start with example number 2. Analyze the beam shown in the figure below by the slope deflection method and draw shear force and bending moment diagram. Here in the first span, point load at the center, in second span UDL, and in third span the point load is not in middle, it is the eccentric. So how we can get the shear force and bending moment diagram for this continuous beam? So we have all the steps. So in our first step, that is fix end moment, and how we can get that fix end moment, we know. For the MFAB, it is equation minus WL by 8, MFBA plus WL by 8, MFBC minus WL square by 12, MFCB plus WL square by 12, and here little bit change in span CD because it is eccentric load. So for that, MFCD is equal to minus WAB square upon L square, and for MFCD plus WBA square upon L square. Here little bit change in the equation. Now step number 2, slope deflection equation, and for that we have equation of slope deflection. MAB is equal to MFAB plus 2 EI upon L, 2 theta A plus theta B minus 3 delta upon L. This equation is common for all. But what we are going to do over here? We are going to find first unknown and put that values in this equation. Which are the unknowns? Here three span continuous beam, and support B and support C both are hinge support. That's why here unknown is theta B and theta C, both the unknowns, and we are getting this equation in the form of that two unknowns. Here we have three span, that's why we are getting 6 equations. Now step number 3, equilibrium equation. So what is the equilibrium equation? Here we have two support which has point pin support. So equilibrium equations are moment from B to A plus moment from B to C is equal to 0. In that equation we have summation of two equation, and what we can get here 3.67 EI theta B plus 1.33 EI theta C is equal to 4.5. That is indicated by equation number 1. And the second equilibrium equation is moment from C to B plus moment from C to D is 0. And we can get the equation 1.33 EI theta B plus 4 EI theta C is equal to minus 0.89, and it is indicated by B. Now we can solve these two equations. We can get the unknown theta B and theta C. Theta B is clockwise and theta C is getting minus, that's why it is anti-clockwise. Now put these two unknowns in our step number 2, and we can get the final moment at support. MAB, MBA, MBC, we get this 6 value. And here the most important thing is moment from B to A and moment from B to C, both the values are same. And moment from C to B and moment from C to D, both the value again same, because it is a single joint, and single joint पे हमें always moment same ही मिलेगी. Now next step, that is span moment. For span AB, WL by 4, span BC, WL squared by 8, and span CD, WAB upon L. So from this span moment, first we are draw the simply support bending moment diagram, and afterwards we are draw the negative diagram, that is support moment, which is indicated over here. So connect these all values by lines and get the bending moment diagram. Same way reaction for the shear force diagram. So for 3 span we are getting 6 reaction, and with the help of that reaction we can draw this shear force diagram, which is indicated over here. So friends, this method is very much simple, and once we get the values of unknowns, we can find all the support moments, span moments, and we can draw easily shear force and bending moment diagram. Now in our next lecture we are understand the if support is sinking, then what is the change in this method is discussed in our next session. Till then, thank you very much.